Welcome to this module on Hugging Face. Throughout this module, we'll delve into the Hugging Face tool and learn how to use its various components. As previously mentioned, Hugging Face can be considered a GitHub for English language models. Hugging Face has developed an open source platform that provides access to a variety of pre-trained natural language processing models. Furthermore, it has recently launched an update to its Transformers libraries that enables compatibility between PyTorch and Google Chrome. Additionally, the Hugging Face platform within the Transformers library hosts more than 3 pre-trained models. Many of these models are built on the same technology, but their transformation models differ. For example, the Google Chrome model is a transformation model that utilizes Google Chrome technology. The Transformers library contains over 3 pre-trained models. Many of these models hail from some of the world's largest tech companies such as Google, OpenAI, and Facebook, and include a pre-trained models like the one developed by Google, the BERT model, the GPT model, Google's Transformer XL, XLNet, as well as the Roberta or DistilBERT models. We have access to a vast array of models for utilization. The Hugging Face Hub, as mentioned earlier, is the central platform that houses a large number of resources. This hub offers pre-trained models, datasets, and spaces with code snippets and demonstrations of certain model uses. These resources can be loaded easily and are available under various licenses, offering users significant flexibility. Moreover, the Hugging Face Hub provides several specialized libraries that greatly aid our work in the field of natural language processing. On one hand, we have the Dataset library, which offers methods and tools for downloading and accessing relevant datasets from the hub. This greatly accelerates the data acquisition process for the training and evaluation of our models. Then we have the Transformers library, one of the most important and popular libraries from the Hugging Face Hub. This library is crucial for workflow development as it simplifies and enhances the use of tokenizers, models, and all the key components in natural language processing. It also enables the download and use of pre-trained models directly from the hub, saving us considerable time and effort during the training stage. Finally, another significant library is the Evaluate library. This library provides a series of functions and tools to evaluate and measure model performance. This is crucial to understand the effectiveness and quality of the models developed, allowing for improvements and adjustments as needed. To illustrate how popular this library is, consider this graph showing different libraries widely used in the data science field. On the vertical axis, we have the number of stars on GitHub, and on the horizontal axis, the dates. Noteworthy tools such as Jupyter Notebook, shown in blue, Apache Kafka, shown in green, or even MongoDB, shown in yellow, have taken many months or even years to reach approximately 15,000 stars. However, Hugging Face in a very short time since its launch around late 2018 reached this number of stars incredibly quickly, in practically a month. Thus, we can see the popularity of this tool and how extensively it is being used today, especially in the field of large language models and natural language processing. The success and popularity of the Hugging Face platform are reflected in the increasing number of questions and queries related to the Transformer library on platforms like Stack Overflow. This library is likely so popular because it offers very intuitive and easy to use APIs, which hide the complexity of the underlying deep learning libraries such as PyTorch, TensorFlow, or JAX. Known for their power and capacity in the field of machine learning, these libraries, thanks to Hugging Face, become accessible even to those with less experience in this field. This is probably one of the reasons why this tool has gained such popularity in recent months. In this task, we will learn more about the Hugging Face interface and how to use it. After accessing the official Hugging Face page, we are redirected to the homepage displayed here. At the top, we can see different sections for models, datasets, and documentation. Once we have selected the section we wish to visit, such as models, we will be redirected to that section upon clicking on it. We will see an extensive list of different models. At this point, it indicates there are 29,000 models available. On the left, we have various filters and selectors that we can use to refine our search. After employing these filters and selectors and choosing a model, we click on the model which redirects us to the official page of the selected model. There is a model card section with more detailed information about the model, and in the Files and Versions section, we find the files corresponding to the model. Now we will proceed to simulate the model search in the Hugging Face interface. We would enter the Model section, where we can observe the different filters available for the models. They are categorized by multimodal, computer vision, natural language processing, audio, tabular, and reinforcement learning. We could also filter based on libraries, the datasets used to train the model, languages, the type of license, and an other selector. Suppose we want to use the BERT model. We can search for it directly in the search bar to find the base model of BERT. Alternatively, we might want a German model. We search for German and it suggests German sentiment BERT, which is used for sentiment identification in German text based on the BERT model. Conversely, suppose we want a model for text classification. We navigate to Natural Language Processing, then to Text Classification, and here we can find various available models. We can select any. In this case, it might be the base model of Distill BERT, which is optimized with a set of English text called SST2. Here we find comprehensive information. We see the model card with additional details about the model, a Get Started section with the code needed to utilize it, a list of uses, and information about the model's training. In the Files and Versions section, we find different model files, and in Community, there is a series of questions and issues about this specific model. On the other hand, suppose we want to search for a specific dataset to optimize a particular model. In this case, we would need to visit the Datasets section. As seen before, we have different filtering options, numerous datasets, and we can select based on task, size, subtask, languages, licenses, and others. Suppose we want to optimize a model for text summarization. We select Summarization, and here we can find the datasets that can assist us. We could select one, and here we see a smaller version of the dataset. We also have a dataset viewer to review the dataset more effectively, followed by additional information about the dataset, about how many records it has, etc. In Files and Versions, we would find the corresponding files and then information in the community. Having learned more about Hugging Face interface in upcoming tasks, we will learn about the components and how to access these models and datasets. In this task, we will learn how to generate a customized pipeline. The default pipelines provided by Viewing Faces only support certain predefined scenarios listed in the basic tasks. For unique scenarios, we must create a pipeline using pre-trained models or by designing our own models. Thankfully, Viewing Faces maintains a repository of models known as the Model Hub, which is a collection of pre-trained and fine-tuned models for all the tasks previously mentioned. These models utilize a variety of transformer architectures, such as GPT, T5, or BERT. Therefore, we can rely on this Model Hub to choose a model that aligns best with our requirements. In this task, we will learn how to leverage these models and create our own pipeline for a specific use case, such as text translation. The first step is to import and initialize the Tokenizer. It is crucial to note that transformer models cannot process text without prior processing. It must be converted into a numerical vector so that the models can interpret the data. This conversion is the primary function of the Tokenizer. Hence, we will import a versatile function, the AutoTokenizer, which facilitates the loading of the Tokenizer. The initial action is to load a tokenizer that is compatible with the translation model we plan to use. We do this with the From Pre-trained function of the AutoTokenizer. We pass it the name of our chosen model, and the function will then select the appropriate tokenizer for the specified model. Consequently, we define the tokenizer, and to modify the input data, we only need to feed it the data, in this case a series of articles, alongside additional parameters such as maximum length for setting the maximum length, and return tensors set to the PT to ensure compatibility with PyTorch. Having acquired the tokenizer, we can now move on to the model. The process is to import the pre-trained model in the same manner as we did with the tokenizer. We will use a function, in this case AutoModel4Seq to seq LM, which converts text into numerical formats. To perform this task, we have to invoke this function, and with the From Pre-trained method, pass it the name of our model, thus obtaining it. Following this, we employ the AutoModel for sec-to-sec LM function. Here we have an example where we retrieve the model that enables us to translate our text. If we refer to the official Transformer documentation under the Model section, we can find various functions for loading a model. For instance, there is also AutoModel, into which we can feed the name of the model to acquire it. Having obtained both the tokenizer and the model, it is now time to consolidate all the steps into a single pipeline. The process involves connecting all the components. We first apply the previous defined tokenizer to our text. By invoking the tokenizer function and passing it in the text, it transforms the text into a set of numbers that the models can interpret. What is tokenizing? Essentially, it involves breaking the text down into words and then subwords, subsequently assigning each token an integer. Upon initializing the tokenizer, we then use it to derive the tokens from the input text. The output from the tokenizer is a dictionary containing two keys, inputs ID and attention maps. Inputs ID represents unique identifiers of the sentence tokens. Meanwhile, the attention mask is used to group the input sequence and indicate to the model whether a token should be attended or not. A token with an attention mask value of 0 will be disregarded, whereas a value of 1 implies the token's importance and its necessity for further processing. After acquiring the tokens, we feed them to the model, which then generates an output vector. With the batch function, we pass the tokenized text to the model, which translates the sentence. The model's output is the translated sentence but in token format. The final step is to convert tokens back into natural language, and this is achieved with the last line of code. We use the batch.decode function, and by doing so, we feed it the translation obtained by the model previously, and it ultimately returns the translated text in natural language. By following these steps, we can generate our own pipeline by selecting a specific model and a compatible tokenizer. Consequently, we can create additional pipelines for unique use cases that might not have been accessible with the default base pipelines. In this task, we will explore the final component of Hugging Face, the Datasets library. The Datasets library simplifies the downloading of any dataset from Hugging Face. It is an API designed for effortless downloading and sharing of datasets. Moreover, it provides datasets for various tasks such as natural language processing, audio, and even computer vision. These datasets hosted on the Hugging Face hub can be filtered by size, task, license, language, and even by the size of the dataset we currently have. Furthermore, we can identify models linked to a specific dataset. So, how do we access these datasets? Through programming, which is quite straightforward. We need to import the datasets function, specifically the load dataset function, to load the dataset. Then, we pass the name and version of the dataset to this function. It is a straightforward command that allows rapid importation of any dataset. By checking out the official dataset documentation within Hugging Face, we can find extensive information on how to utilize it. As previously noted, there are datasets not only for natural language processing, but also for computer vision and other applications. Let's consider this initial quick start example where a dataset from Microsoft Research is accessed. To retrieve it, all that is required is to use the load dataset function and pass the name of the dataset. The split argument set to train is used to divide the dataset. Next, they will use BERT to classify the text. They input two text strings, aiming to compare them to use if both sentences convey the same meaning. How is this done? It is quite straightforward. They start by obtaining the auto model for sequence classification and the auto tokenizer from the Transformers library. The first step is to load the model using the function they have just imported and pass the name of the model, which is the base model of BERT. A tokenizer compatible with the model is also needed. To get the tokenizer, they use the AutoTokenizer.FromPretrained function, passing the model name as an argument, which retrieves a tokenizer compatible with BERT. The final step is to tokenize the two input sentences and feed them into the model to get the result. Once the two input sentences have been processed with the tokenizer, resulting in word IDs and attention masks, with 0 indicating the token should be ignored and 1 signifying attention should be paid, these tokenized sentences are then passed to the model. The model then determines whether they convey the same meaning. As we have just seen, downloading any dataset within Hugging Face is remarkably simple, and the platform also offers a wide array of datasets to cover practically any use case, whether it is for natural language processing, computer vision, or audio processing. Welcome to this hands-on lab of Hugging Face, where we will begin to use this Hugging Face tool to access various pre-trained large language models. As we previously mentioned, Hugging Face is a kind of repository, sort of like GitHub for large language models, where we can access different large language models. Here we can obtain a multitude of already trained large language models ready to be used. Hugging Face has different sections, and concerning the pricing aspect, we have various account types. We have a free version, but it is limited and gives us access to different types of accounts, which allows us to access a limited number of models, but not all. Additionally, it offers community support, and we can also host our models without limits. With the Pro account, we'll receive many more benefits, such as access to new features and capabilities, as well as broader access to the Inference API. We can also use AutoTrain. Moreover, there are different subscription types. In our case, we will start with the free account, for which registration is required. Once we have completed the registration and created our user, we can use some of the models. To access them, we go to the Models section. As we know, on the left, we have filters that can be applied based on tasks, libraries, datasets, and types of models, among others. For our purposes, we will use the task filter and look at multimodal models, computer vision, natural language processing, audio, tabular, or reinforcement learning. We'll choose a simple natural language processing model for text classification. Therefore, we filter by text classification and select the Roberta model, which determines the sentiment of tweets. On the left side, we find more information about this model. It indicates that Roberta has been trained on over 124 million tweets from 2018 to 2021. It also provides details about the paper describing the model and the repository where it is hosted. This model returns 3 labels, 3 for negative sentiment, 1 for neutral, and 2 for positive. It also provides access to the Python code we must use to consume this model, which is as simple as using the pipelines we had mentioned before. The pipeline consists of 3 main features: text preprocessing, which converts the text into numbers, the trained model itself, the large language model, and a post-processing phase so we can understand the returned result. The process is as simple as importing the pipelines from the transformers and using the sentiment analysis one, specifying the model's path and the tokenizer. Then we give it a sentence to classify and it returns the result. We also have a more advanced example where a series of tweets are analyzed using a different tokenizer. Finally, at the bottom, we find the model's references. Another interesting feature is that on the right side, we can directly test the model. For example, when analyzing the phrase "COVID cases are growing very rapidly," the result is 73% negative, 22% neutral, and barely positive at 0.05%. When testing another phrase, like "the movie was amazing," we get a positive sentiment of approximately 98%. As we can see, using the models from the right side is straightforward. Now that we have explored how to navigate the Hugging Face environment, how to select a model, and how to use it within the interface, the next task, we will see how to integrate these models into feature applications using Python code. In this task, we'll explain how we can integrate the models from Hugging Face into our applications using Python code. As we mentioned in the previous task, the models themselves provide the Python code we need to use. However, in order to utilize these models, it is essential we have an API key to integrate them. We will head to the Inference API section. Here we will find support for different programming languages, code in Python, in JavaScript, and also access through application calls. If we look at the Python section, we will notice a URL that needs to be called to access the application. We also have various programming languages and calls to the URL that will allow us to consume this model. Yet, in addition to the URL, an identification token or authorization is required to grant us access to the model in question. To obtain the token, it is generated from the token section. Here we can view existing tokens or create a new one from New Token. When clicking on New, we will be asked to assign a name and role to the token, having the choice between a read role and a write role. After creating the token, we return to the previous section, select the role and the newly generated token. Then we refresh it to appear on the list, and finally we copy it in its entirety. Once we have copied the token, we can go to any Python environment and use this model. For demonstration purposes, we will create a new notebook in Colab, but it can be done in any environment. We paste the previously used code and execute it. Upon completion, we can see the result, which in this case shows a sentiment for the entered phrase with a score of 93% positive. As can be observed, using this model is quite straightforward. Additionally, there is no need to install anything else since Request is a library that comes pre-installed in Colab, and the model doesn't require installation as it is hosted on Hugging Face. Our primary task is to make queries through the Hugging Face API. Now we move to the notebook Hugging Face Inference API, where the previous example is located. Here we can directly access the array of interest. It is clear that the response is a dictionary that doesn't only return a single label but displays the 3 labels with the percentage of affiliation to each one. We can select the first one and, if we wish, order the labels based on their score to quickly identify which is more relevant. In this case, when sorted by score, we see that the label of utmost importance is label 2, which corresponds to a positive sentiment of 97%. If we wanted to change the names of the labels, we could do so through mapping. For instance, we could assign label 0 the name negative, label 1 neutral, and label 2 positive. Thus, using this mapping, it would indicate to us that label 2 is positive. It is worth noting that the Twitter Roberta-based sentiment model was an initial version. In its latest version, instead of providing label 0, 1, and 2, it offers labels like positive, neutral, and negative, which is much more intuitive. In conclusion, it is easy to utilize the pre-trained models from Hugging Face. Within this platform, there is a vast variety of language models specializing in different tasks. We can choose and use the one that best fits our application needs with ease. In this hands-on lab, we will explain how to use models from Hugging Face through Flowise. The first thing we need to do is create a new project. To use a Hugging Face model from Flowise, at the very least, we will need the A1. Within Flowise, this is referred to as the LLM chain, followed by the Hugging Face model called Hugging Face Inference. We'll begin by searching within chains. We know various components exist, but in our scenario, we'll select the most basic one. It is vital to recall that we must add a prompt to the LLM chain. For this reason, we'll incorporate a prompt template. In this section, we'll specify the instruction we wish to convey to the model. For instance, we're requested to produce a joke about dogs. After accomplishing this, we will proceed to link it. The next move is to integrate the Hugging Face model. For this, we will access the LLM section, as these are the entities responding to the commands. This is where we'll utilize the Hugging Face inference, providing us access to the Hugging Face models. As expected, credentials will be sought to move forward. Though we already have a set that was generated earlier, there is an option to create new ones. For this purpose, we should choose Create New, where we will be prompted for the credential name and Hugging Face API key. Remember, the API key can be sourced from the apply_td deploy in the Inference API. Once there, one can view the token or, alternatively, log into our account, navigate to Settings, and within the Access token, copy it. With the token copied, we input it into the relevant field and select our model or endpoint. To identify the model's name, we merely copy it from its primary source. If seeking the endpoint, we'll navigate to the deploy section and retrieve the address from there. For this exercise, we'll opt for the GPT-2 large model, which is available with the free account. However, it is paramount to understand that while smaller models are accessible in the free version of Hugging Face, the larger models often necessitate a paid subscription, exceeding the bounds of free access. Fortunately, in this case of the GPT-2 Large, it is compatible with the free version. Once the project is linked and saved, we move on to test it. The response might take some time, but eventually it will deliver the result of the instruction initially provided in the prompt template, which in this instance is a dog joke. If we wish to alter or customize the output, such as changing the joke type, we can input variables as we learned earlier. However, it is worth noting that GPT-2, being an older and less advanced model than GPT 3.5 from GPT-A, might not yield the most optimal results. In summary, through this lab, we have demonstrated that employing Hugging Face models from Flowise is straightforward and direct. With the right components, we gain access to a wide variety of pre-trained models available on Hugging Face.